Hi, I'm going to do a sample problem, easy momentum problem, and I'm going to show you two ways to solve it. And a couple of my examples will show you both ways to solve momentum problems. Whichever way works for you, I don't care which way you go. So the problem I'm starting with. A candy-filled piñata is hung from a tree for Sarah's birthday. During an unsuccessful attempt to break the 4.4 kilogram piñata, Hayden corrects it with a 0.54 kilogram stick moving at 4.8 meters per second. The stick stops and the piñata undergoes a gentle swinging motion. Determine the swing speed of the piñata immediately after being hit with the stick. All right, that's our problem. So what do? We start with a picture, of course, and just like with energy, we care about initial and final, so we have to make sure we're drawing a picture that shows initial and final. So, okay, tree, that's a tree, and there's a piñata, and I'm not a very good drawer, so that's a piñata, very boring piñata. So initial is, there's a stick, I don't know, I guess I'll draw a bat. Someone's swinging a bat to the piñata. And in the final condition, the piñata is moving. Okay, so initially the piñata itself is at rest and the stick is moving with some speed. And then here the stick is stopped and the piñata is moving. So there's my initial, there's my final. Let's see, what do we know? We know the mass of the piñata was 4.4 kilograms. The mass of the stick was 0.54 kilograms. The initial velocity of the stick, let's see here, what do we have? Initial velocity of the stick was 4.8 meters per second. The initial velocity of the piñata was nothing, that was at rest. The final velocity of the stick was 0. The final velocity of the piñata is what we're looking for. All right. So picture, initial, final, knowns, unknown. And now we have to be careful because now we are dealing with velocity, not speed. Velocity is speed plus direction. So I'm going to say that the stick's initial velocity, the velocity initial of the stick was to the left. Which means that's a negative. And then the final piñata will probably be to the left too. I mean, you know it will be. All right. We've got our knowns or unknowns. We've got my speed, my velocity. I have to be careful. There. Okay. P initial equals P final. That is the conservation of momentum. Initial momentum, final momentum. So what is the initial momentum? Well, we have two objects, so we have to take into account both of those momenta, is the plural. So that would be the initial momentum of the piñata plus the initial momentum of the stick equals P final piñata plus P final of the stick. All right, and we can make our life a little easier right away by saying, oh, we know two of these are 0. The initial of the piñata was 0, so there is no initial momentum of the piñata. The final stick is 0, so there's no final momentum of the stick. So many things to keep track of. All right, which means my equation actually doesn't look that bad. P initial of the stick has to equal P final of the piñata. Momentum is mass, stick, velocity initial of the stick. Momentum is mass, not piñata. V final piñata. You are going to need to keep your subscripts in order for momentum because you're going to have a lot of this type of thing. And it might get even more, well, it will get even more complex once we deal with 2 dimensions, once we have up, down, left, right. But for now, we're starting with an easy one. We know mass, right? Yep, we know the mass. We know initial velocity. We know mass of the piñata. We're looking for that. Pretty straightforward. Okay, so V final of the piñata is going to be mass stick, V initial stick over mass piñata. Mass of the stick, 0.54. And velocity, don't lose that negative, It's important. It gives you important information. Over mass of pinata, yep, 4.4. All right, you do the math? Go get your calculator. Give it a try. What do I get? What did I get? I got V final of the pinata to be, now, just a real quick thing. Would you expect it to be moving faster or slower than the stick? The stick is very lightweight. The pinata's heavy. So if the stick was moving at almost 5 meters per second, just stop and say, would I expect a reasonable answer to be faster than that or slower than that? Hopefully, your brain says, well, it's got to be moving slower because it's more massive. And that's what we get. We get negative 0.59 meters per second. Negative meaning it's going to the left in the same direction that the stick was, which makes sense. And it's quite small. It's very small, in fact. The cool thing about momentum is in a situation as simple as this, it's just a ratio. So the ratio of the masses has to equal the ratio of the velocities. So if you're somebody who likes to solve things by ratios, give it a try. See if you can get that same answer just by saying, the ratios have to be equal. All right, so that is one way to solve this problem. Now I'm going to show you a second way using a table. Kind of like we used tables with the forces or anything with components, really. So I'll erase this and then show you the other way. Okay, so the second way is a table method, and what you're going to do is you're going to set up a column with initial momentum, a column with final momentum, and then for every object you're going to set up a row and we'll figure out what's what. So stick, initial momentum, yeah, we definitely have that. So that's MV, that was 4.4. Whoop, nope, that's not the mass of the stick. Try again. 0.54. Try again. Oh, that's right. It never erases well when it's wet. Okay, how about 0.54 and negative 4.8? Okay, the final momentum of the stick is 0. The initial momentum of the piñata was 0. The final momentum of the piñata, well, we don't know. So what I'm going to do here is I'm just going to say, well, it's m times v. We do know the mass, that's the 4.4. So this is 4.4 times v final of the piñata. Okay, so first step is you fill in whatever you know of the boxes here. And now we're going to add them up. So what is the total initial momentum? Add everything up. It's going to be whatever this is. And what's that number? Negative 2.592. Negative 2.592. Okay. And this we have 4.4 V final P. I can't add that. There's no number yet. All right, so how do I figure this out? Well, conservation means this has to equal this, which means the total initial momentum has to equal the total final momentum. So I can just take this number and say that has to be the same as this number. Negative 2.592. Okay, so that column is all clear. Now I can use this column to actually solve for my unknown. 4.4 V final piñata has to equal negative 2.592. You solve that, and you get the same answer we had before, negative 0.59 meters per second. So that's the second way to solve it with a table method. Whichever way makes more sense to you, use that one. I'll do a couple more example problems showing you both ways so you can get a sense of, I kind of like this one, or no, that doesn't make any sense. But this is just a nice straightforward 2 objects, 1 dimension, and lots of zeros. So yeah, quite an easy problem. But there's your start at figuring out momentum problems. Good job.